My name is Mariel, and I'm a PhD student in music theory and composition. In my creative practice, I work from a sociological perspective. I'm interested in process and directionality, how process creates artwork, and how much the process influences the end result. My question is, could you describe the qualities of a cohesive force that keeps a group of things together, and also the limitations of that, by which I mean when that group is no longer held together, what's the process of separation?
Sure. I think one of the most important cohesive forces in the natural world is the cohesion between water molecules. So I think we've all seen this. If you put a drop of water on a smooth surface, it beads up into a little ball. It doesn't just spread out. I mean, if you put, for example, alcohol, which has very little cohesion down on the surface, it will spread out and make a very thin, very flat layer. But water doesn't do that. Water has a very substantial force of interaction between molecules. It's because they have what's called a dipole moment. They have a separation of charge. One end of the water molecule is a little bit positively charged. The other end is a little negatively charged, like a little arrow. And when the arrows are all together, the positive end of one arrow would like to be next to the negative end of its neighbor. And so the arrows tend to line up. It turns out that force is of profound significance in the structure of all living matter. It affects how molecules within cells interact with each other, whether they choose to interact with water or with other molecules that are not water. It determines the structure of rain. That rain comes down as little droplets. It would be totally different if instead of water we had ethanol. Ethanol would not come down as little droplets. So it's one of those fascinating cohesions in nature that you kind of don't even notice or take for granted. And yet, if it weren't there, the planet would be completely different, be a completely different world without water's cohesion.